Ionic compounds are made of cations and anions. Most of the ionic compounds in this course have a metal cation. Thus, we can identify an ionic compound by the presence of a metal in the formula or name. Ionic compounds are held together by ionic bonding. We'll talk more about ionic bonding, but first we need to discuss what ionic bonding is not. Ionic compounds are not made of molecules. Molecules are made of two or more atoms bonded together. The image on this slide is the model of a molecule of ethanol with 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. The cylinders connecting the atoms represent bonds or shared electrons and are called sticks in a model. Ionic compounds are not made of molecules. The ions stick together because of the attractive forces between the positive and negative charges of the ions. Each cation is surrounded by anions, and each anion is surrounded by cations in a structure that minimizes repulsive forces between like charges and maximizes attractive forces between opposite charges. On this slide, we have a model of the structure of the ionic compound sodium chloride, where the smaller purple spheres represent the sodium cations and the larger green spheres represent the chloride anions. An actual grain of salt would contain trillions upon trillions of cations and anions. No individual molecules exist. Instead, an extended structure of trillions upon trillions of cations and anions. Ionic compounds are always solid because each cation must be surrounded by anions in a specific location and vice versa. Like refrigerator magnets, the attractive forces of ions depends on distance. If you remove a refrigerator magnet too far from the fridge, the attractive force is no longer strong enough to make the magnet stick. Ions of opposite charges need to be close to one another to remain bonded or stuck together. Solids are stolids because the ions or atoms in the solid are not moving past one another.